All right, welcome back. The effect of the alkyl and functional group. Now, the functional group determines the chemical properties of a compound, while the alkyl group affects the physical properties of a compound. So that means that all the reactions that take place in an organic compound is caused by what? The presence of the functional group. Whereas the things that you can see, like the color, the melting point, the boiling point, is caused by what? By the alkyl group of the organic compound. All right. The polar hydroxy group in the alkanols promotes solubility in water, but the non-polar alkyl group opposes it. Because of what? This is the functional group there, this is OH, encourages what? The solubility of alkanol, for example, which is the functional group of an alkanoid. Okay, now these are some examples of homologous series and their functional group. We have more, but these are the basic. We have the alkanes, general formula of RH. Now this R shows that it can be any of the alkane. It can be methane, it can be alkene, and so on. Then what is the functional group? Just a single bond in between their carbon atom. Then we have the haloalkanes. Haloalkanes are derived from the halogens, like the group 7 elements. For example, we have the fluorine, chlorine, and the bromine. We also have the alkenes. Alkenes contains double bond as a functional group between their chain. Then the alkynes, triple bond between the longest chain. Then the alkanoic acid, general formula of R. R here stands for the alkyl group, whereas COOH is what is the actual functional group. So any compound that contains COOH must carry what? An alkyl. It can be ethyl, it can be ethanoic acid, it can be propanoic acid, it can be butanoic acid, and so forth. Then alkanoids called esters contains COO as a functional group. This is R and R prime are all alkyl group. For example, it can be ethyl metanoate, ethyl propanoate, and so on. Alkanals, also we have CHO as the functional group, as you can see. But general formula is what? Is RCHO. This R is an alkyl. It can be methyl, it can be methanol, propanol, pentanol, and so on. We have the alkanones. Functional group of CO, then R prime represents what? Their alkyl group. Okay, let's continue. The alkyl groups derive from the first 4 members of the parent alkane series. We have done it before. For example, the methane is from the alkane. Methane is CH4, normal formula. Then, if you want to derive the alkyl group, we have shortest of what? 1 hydrogen atom, which is dash CH3. Same thing with ethane, C2H6. From ethane, we have ethyl, C2H5. Then propane, C3H8. Short 1 of hydrogen atom, we have what? C3H7. Then butane, butyl. We have propyl, propane, propyl. We have hexane, hexyl. We have heptane, and so on. Okay, characteristics of homologous series. All members of the series a general molecular formula, in which I showed you before. Each successive members is a series differ in molecular formula by addition of the CH2. We have discussed this already. Then each successive member differs in relative molecular mass by an increase of 14. How do we get 14? We have the CH2 here. The molar mass of carbon is 12. So 12 plus 1 times 2 give us what? 14. So it's always increasing by what? By the molar mass of 14 per homolog present in the homologous series. Chemical properties of the members are similar, but a gradual variation along the series. They have the same chemical properties, but as it goes down the group, there are some little changes. Then the physical properties change gradually as the number of the carbon atoms per molecule increases. Example, boiling points. The boiling point of each of the homologous series increases down the group. For example, we have the propane, we have the ethane, and so on. Propane has the least boiling points. As it goes down the group, the boiling points increase based on what? The increase in the carbon atom present. All members can be prepared by the same general method. So homologous series, they have similar characteristics in terms of their chemical properties, mode of preparation, and so forth. Okay, formula of organic compounds. We have three basic formulas with regards to organic compound. The first one is called the empirical formula. Empirical formula is the simplest formula of a compound. It's the simplest, but it will not really give you the exact atoms present in that particular compound, but it's the simplest to know. It indicates the relative number of each kind of atom present in the molecule of a substance. It is found by determining the composition of the substance by what? Quantitative analysis. The next one is called the molecular formula. Now, molecular formula is gotten from empirical formula. That means that without empirical formula, there is no molecular formula. Okay, so this is a more useful formula than what? Empirical. It indicates the actual number of each kind. That means that how many carbon atoms are present in a particular homologous or in a particular hydrocarbon. This will be determined by what? By the molecular formula of that particular hydrocarbon. The molecular formula is deduced from the relative molecular mass and the empirical formula of the substance. That means that without empirical formula, we cannot deduce what? The molecular formula. The next is the structural formula. Now, this shows how each of the atoms in an hydrocarbon have been what? Spread. Okay, the structure of each of the carbon. For example, okay, this is used to represent a particular organic substance, indicating how atoms are arranged within what? The molecule of a substance. As we have earlier illustrated using the alkane, butane as homologous series. Okay, how can we calculate the molecular formula of a compound? It's very simple. For example, let's do this together. The empirical formula of a given compound is C2H4O. Now, this is empirical formula. Okay, so from here we can do what? Get our molecular formula. And its relative density is 44. The question is, determine its molecular formula. Now, this is not the actual formula of this compound. It's just like a mirror formula that will lead you to the actual formula. So how do we get it? Now, let's go like this. Don't forget that molar mass equals to relative density times 2. So once a question comes with relative density, you must do what? You must multiply it by what? By 2 to get the actual molar mass. If not, you get the answer wrong. Because relative density is given as half molar mass. So if you are looking for vapor density here, you have to cross multiply and do what? This times 2 give us a molar mass. So if you don't do that, you will not get the actual what? Answer. So 44 times 2 give us what? 88. Now this is numerical formula equals to empirical formula equals to what? Molar mass. So you lift the empirical formula from the question because it was given directly. C2H4O bracket N equals to what? 88 from where? The molar mass just derived. Now, expand through and get the molar mass of the empirical formula. So 12 times 2 plus 1 times 4, then plus 16. These are their respective what? Molar weights. 12 for carbon, 1 for hydrogen, then 16 for what? Oxygen. If we sum them together, you have what? 44N equals to 88. Now let's find N. N equals to 88 divided by 44. That gives us what? 2. Now leave this 2 to N, which is bracket C2H4 close down N. So we take the value for N with 2. You have C2H4O close down 2. Then multiply, open the bracket, you have C4H8O2. So now this is the actual formula of this homologous or this organic compound, C4H8O2. Whereas C2H4O is empirical formula, whereas molecular formula is C4H8O2. This shows the actual number of atoms present in that compound. Okay, the IUPAC nomenclature of organic compounds. If you must pay attention in this particular section because these students have problems a lot. How to name organic compound. Now, there are a set of rules you need to follow for you to be able to do what? To name organic compound correctly. Now, let's take the rule first. Rule 1 says, select the longest continuous carbon chain as the root hydrocarbon and name it according to the number of carbon atoms it contains, adding the appropriate suffix to indicate the principal substituent group. Now, it's what we call suffix and prefix in normal English language. Bring that idea to chemistry. Suffix means word after, whereas prefix means what? Word before. So, at the course of naming, we shall get to know more on it. Then, rule 2 says, number the carbon atoms in the root hydrocarbon from the end, which will give the lowest number to the substituent. Now, what is a substituent? A substituent is an atom or group of atoms other than hydrogen that is attached to a carbon atom of the parent hydrocarbon or chain. This is rule number 2. Then rule number 3. Okay, the substituent may generally be alkyl group or radical or halogens. The halogens are indicated by the prefixes. If it is fluorine, you call it what? Fluoro. If it is chlorine, you call it what? Chloro. If it is bromine, you call it what? Bromo. If it's iodine, it's called iodo. So these are all prefixes or suffixes depending on the position in the organic compound. Rule 3 says, if the same substituent is present 2 or more times in a molecule, the number of this substituent is indicated by a prefix di. Means that di means 2, tri means 3, tetra means 4, etc. Attached to the substituent's name. The location or position of the substituent is given by a separate what? Number. Note this rule very well because we start applying it very soon. If you have the same substituents more than 2 in a compound, you add the prefix di. If it is 3, it's tri, and so on. Then rule 4. If there is more than one type of substituent in the molecule, the substituents are named according to the alphabetical order. But where there are mixed substituents, the inorganic are named first. This means that when you have a mixture of organic and inorganic substituents in an organic compound, you give preference to what? To the inorganic element first. Before you do what? You name the organic substituents, like the chloro and the methyl. So chloro comes first before what? The methyl. We have bromo, we have ethyl, we have methyl. All the inorganic, fluoro, bromo, iodo, come first before you name the other organic substituents present. Now, the final rule. In selecting and numbering the longest continuous chain, the functional groups are given preference over substituents. So, whether you have 10 substituents in one organic compound, you give preference to what? To the functional group. It can be alkene, can be alkyne, can be alkanol, can be carboxylic acid. You consider those ones first before naming any other substituent present. The functional group is given the smallest possible number. Okay, on this note, let's go for a brief break. When we come back, we continue.